here we are again, more on graphing. So this section, just like we promised, this is going to be a different method on how to graph lines, or it's actually not a different method, it's more specific, saying, there was a lot of freedom when we graphed lines in this previous section. If you remember, you can choose whatever you want, and also you can choose X or Y to pick the value of. I think that's almost too much freedom, and people think they're doing it wrong because, math is usually there's one way to do it. So if you're in that boat and you say, whoa, there was way too much freedom in that section, then I think you're going to like the methods from this section. And actually, I think this is my favorite method on how to graph a line. When I graph lines on my own, and I'm not teaching it, I'm just trying to graph it for myself, I always use this method every time. So let's jump into it. But before we get into it, really finding or how to graph the lines, we got a few new definitions in the very beginning that'll help us out. So let's see, at the very beginning here, it says the point at which a line crosses the x-axis is called the x-intercept. So that's good to remember, which makes sense. Okay, intercept means where something, I think of intersect, where are you intersecting? And x-intercept, I would assume that means the x-axis over here. So where is this line intersecting the x-axis? And then kind of analogously, the point at which the line crosses the y-axis, that's called the y-intercept. And that makes sense because this is the y-axis here. And you're just asking, okay, where is this thing intersecting the y-axis? So let's just practice making sure that that concept makes sense. Looking at this graph over here on the right, what do you think the x-intercept is? Where is this line intersecting the x-axis? I'm looking at it and I see that this point right here, that's where it intersects the x-axis, right? And what point is that? It looks like the x-coordinate is 1. Excuse me, because on the x-axis it's hitting at 1. The y-coordinate though is 0, we notice, because it's not above the x-axis, it's not below. So since it's right on the x-axis, you didn't go up or down. You just stayed at 0 on the y-axis. So that point is 1, 0. And then the y-intercept, let me see, where would that guy be? I'm going to get a different color here. Where is this thing hitting the y-axis? It'd be right here, this point. That's where the line, this red line that someone's already drawn for me, intersects the y-axis. And that point looks like it has an x-coordinate of 0 because it's not to the left or to the right. It's right on the y-axis, but it's down 2. So it's got a y-coordinate of -2. So that looks good. I think those are our x and y coordinates, or our intercepts. And I think, I didn't say this out loud, but notice that it says, here in kind of the definition, it says, the x-intercept will always have a y-coordinate of 0. And notice that was true when we actually looked at the line. The x-intercept had a point, it was 1, 0. So notice the y-coordinate is 0. That'll always be true of the x-intercept of any line. An x-intercept will always be something, 0, where that something is whatever the x value is. And then kind of similarly, the y-intercept will always have a x-coordinate of 0. And notice that was true when we looked at the line and we found that the y-intercept, the point was 0, something. So that's true. It's kind of hard to remember because for the x-intercept, the y-coordinate is 0. For the y-intercept, the x-coordinate is 0. So you kind of have to think of the opposite things. X-intercept, y equals 0. Y-intercept, x equals 0. But actually, that observation will allow us to have a way to figure out what the x-intercept and y-intercept are without even looking at the graph. So down here, this is actually what's going to help us graph a line really nicely. So notice in this red box that I just drew, it says, in order to find the x-intercept of an equation of a line, let's say, like down here in example 2, I just have an equation, 2x plus y equals 6. I don't have the graph yet. If I had the graph, that would be one thing, and then I could just figure out the x and y intercepts like we did in this upper problem here. But if I just have the equation, algebraically, this box tells me how I would find the x-intercept and the y-intercept without having to graph it. It's okay, let's try to do that. It says, to find the x-intercept, let's make that our first goal here. X-intercept. As it says in this box here, we're going to let y equal 0 and solve for x. So let's see how that goes. I'm going to rewrite that equation. It was 2x plus y is 6. But like it says, if I want to find the x-intercept, I'm going to replace y with 0 and see what happens. So let's see, where the y was, I'm going to put a 0. So it's then, all it's going to simplify to is 2x equals 6. Because 2x plus 0 is just 2x. And then I can solve that for x fairly easily by dividing by 2 on both sides. Looks like x is 3. All right, and that gives me an ordered pair because remember, I let y equals 0 in the beginning. So the y-coordinate must be 0. And then I found that the x-coordinate was 3. There's one ordered pair. That's the x-intercept. And then the next ordered pair, I'm going to find, like it says, if you want to find the y-intercept, I'm going to do that up here maybe. The y-intercept, it says here, to find the y-intercept, you're going to let x equals 0 and then solve for y. So pretty much whichever intercept you're trying to find, x or y, you let the other variable equal 0. So you want the x-intercept, let y equal 0. You want the y-intercept, let x equal 0. Yeah, let's see. So I'm going to take that same equation, of course. That's the equation we're trying to graph here. 2x plus y is 6. And this time I'm going to replace the x with 0. Not the y, but x. Okay, so it'll be 2 times 0 plus y equals 6. But, 2 times 0, that's just 0. Plus y is 6. But 0 plus y is y. Looks like we get y equals 6. Okay, that means the ordered pair is, well, we let x equal 0. That must mean the x-coordinate is 0. And then y was 6, so the y-coordinate is 6. All right, we got 2 points. We found 3, 0 and 0, 6. And I know in the last section, since we were just learning how to graph lines, remember we said, oh, you should probably have 3 points if you want to be careful, I would say that's probably true in the last section. All the problems you do in section, what was that? In the very first time you graph lines, I'd say probably find three points. But after you do all those problems, that's a lot of problems. I think you're getting the hang of it and you're not really making mistakes anymore. So I think at this point, all you really need are 2 points. 3 is probably good if you want to be safe, but all you need is 2 points. And we found them. And they were really easy to find, right? You notice replacing something with 0 is really nice. I think we had mentioned that in the previous section. We said using 0 ends up making things really nice. So yeah, only 2 points are necessary. I won't really be able to check my answer, but I think if you feel confident enough, then you probably don't need to. But if you did want to check your answer, you could find, maybe find another point, let x equal 1 or something, and see what happens. And if there are 3 points you find, the 3, 0, 0, 6, and this last point, they all line up in a line, then you must have done it right. But if you're kind of short on time, then you want to just find 2 points just to be safe. All right, so I'm going to start off with this point here, 3, 0, that we found that guy. That's the x-intercept, so it's no surprise that it hits right on the x-axis. The other point I found was 0, 6. That guy hits here, and again, that's the y-intercept, so it's no surprise that it hits the y-axis. And all I need to do is connect the dots, and then we're done with that problem. Doesn't that seem way faster and way easier than the last section? Even though we're kind of doing the same thing, you let x equal 0, you let y equal 0. We could have done that in the last section. It's just, now we're saying that we feel more comfortable, and we probably only need to find 2 points as opposed to 3. And you notice they're giving you more direction. They're saying, you don't really have as much freedom, don't find any points, find these specific points by letting x equal 0, and by letting y equal 0. So I noticed in the last example we said, oh, we let x equal 0 and we let y equal 0, and that's how we solve for x. You know what's the easy way to remember that? Is set up a little table like we did before in the previous section, but just set it up always with let y equal 0 and leave x blank, and then let x equal 0 and leave y blank. Because that's really what we did in the last example, right? We found the x-intercept by letting y equal 0, and then we found the y-intercept by letting x equal 0. So that's just kind of an easy way. If you just kind of memorize this little table, and then you don't have to memorize, oh wait, how do I find the x-intercept again? I let x equal 0 or y equal 0? Yeah, you don't have to memorize all that. If you just memorize this table, then you're going to be good to go. This table. I think it's really nice. Yeah, so let's see. Maybe we'll just find the first one, huh? It looks like we're letting y equal 0, because 0 is there in the y-coordinate. So this equation is kind of interesting looking. It's y equals negative 30 plus 3x. But we're going to let y equal 0. So I'm going to go ahead and replace where that y was, which is on the left. I'm going to replace that guy with 0 and then solve for x. Let's see here. So it looks like 0 equals negative 30 plus 3x. And I have to do a little work here to solve for x. I'm going to try to isolate x by moving the 30 over. I'm going to add 30. Then I'll have 30 is equal to 3x is all that's left on the right side since the 30 and the 30 canceled. Then I can isolate x entirely by dividing by 3 here. Alright, so x must be 30 divided by 3, which is 10. Aha. Okay. So that must be the other coordinate of that first point. You can go ahead and replace that here. 10. Alright, let's find the other guy now. Now we're just going to find the y-intercept by letting x equal 0. Let x equal 0. Alright, and the equation was y equals negative 30 plus 3x. But this time I'm letting not y equals 0, but x equals 0. So I'm going to replace x over here on the right side with 0. And that's actually going to work out pretty well. It looks like y equals negative 30 plus 3 times 0 is 0. Negative 30 and 0 is negative 30. So that's not so bad. All right, let's see. Go ahead and take that. Y equals 30, replace that here. Oh, negative 30, sorry. Oh, you know what? I noticed my graph is not big enough, huh? Because negative 30 is going to be way down there. I should probably make this graph longer. Well, you know what we can do? Maybe we'll go, Maybe I'll just make my own graph, because this, you notice, how am I going to plot the point 0, negative 30? It only goes down to negative 10 here. So maybe I'll just make my own graph somewhere else. I'm thinking this graph is too small. Maybe I'll go, I don't know if I have enough room, huh? How about right here? There's not a whole lot of room, but I think we can do it. And then, instead of counting by 1, 2, 3, 4, what if I count by tens? 10, 20, 30. Because I notice the points that I have in my table, the points only have 0s and 10s and 30s in them. So I don't really need the negative 1, negative 2, all those guys. This should be enough. So if you're making your own graph like this, or your own Cartesian coordinate system, feel free to count by whatever you want, 10s, 20s, or 2s, or whatever it is, if you have large numbers. This doesn't happen too often, but if you happen to have large numbers, it's not a bad idea. All right, so our points, let me see. That table had, the first row gave us a point 10, 0. The second row gave me a point 0, negative 30. So let me see, that first point 10, 0, 10 on the x-axis, 0 on the y-axis would be right there, which makes sense because it's the x-intercept. And the second point, 0, negative 30 would be, I'm not going left or right since x equals 0, but I'm going down 30. So to negative 30. And that makes sense again because that's the y-intercept. And I'll connect those guys. There we go. Beautiful. That's a beautiful thing right there, you guys. So that doesn't look like the nicest graph in the world, but that's usually what they end up looking like if you're not provided the Cartesian coordinate system, you have to draw your own. I don't know, for me anyway, it never looks very pretty. But hey, as long as you have the right idea, your points were correct and all that, then you should be fine. All right, looks good. You want to do that again with a new problem? Why not? We're all here. We're all ready to have a good time, of course, always. Let's see. So we got another one. They want us to do the same thing. So like right away, if I'm used to this, I'm going to already have memorized this table. First thing, you want to let y equal 0 and see what x is. Then you're going to let x equal 0 and see what y is. So I might as well jump into it. The first thing I want to do, finding the x-intercept, is to let y equal 0. But again, you don't have to memorize that if you just memorize this table, because y is already 0 first, and you're already going to know what to do. I'm going to take the equation I'm given, 3x minus 2y equals 8, but I'm replacing y with 0. So it'll look like 3x minus 2 times 0 equals 8. Okay. And 2 times 0 is 0, so this is really just 3x. You could put the minus 0, but you don't have to, right? 3x minus 0 is 3x. And if I want to solve for x, I'm going to have to divide by this 3. And I realize this isn't a pretty number, huh? But that doesn't mean you necessarily did it wrong. There are just some times where these numbers don't work out very well. So that's my x-intercept. I'm going to put that right here. 8/3. That's not going to be pretty. We'll figure out later. There might be a better way to write that. Or you know what? While it's on my mind, I might do it now. This is, like we said before, this is improper, an improper fraction. Improper fractions are hard to plot, so I'm going to change it to a mixed number. Now, if you remember how to do that, you divide the denominator into the numerator. 3 can go into 8 twice. With 2 left over, that means this guy is 2 2/3. That's probably a lot easier to plot. So I'm going to keep in mind when I try to plot that x-intercept, I'm not going to plot 8/3, 0. I'm going to plot 2 2/3, 0. That'll be easier. All right, let's try the next one. So this next point we'll find by letting x equal 0 instead of y. All right, but the same equation, of course. The equation was 3x minus 2y equals 8. And this time 0 is going where x was, not where y was. 0, all right. 3 times 0 is 0. Minus 2y is negative 8. But, 0 minus 2y, that's just negative 2y equals 8. And now I'm ready to solve for y by dividing by negative 2. Y must be 8 divided by negative 2 is negative 4. And that's not a bad number. I mean, that one, I don't really worry about graphing that guy. That's a nice number. So that must be the y-coordinate of the second point. Okay, so if I want to gather my thoughts over here, the 2 points I'm plotting are 8/3, 0, which, like we said, I don't really like. That's going to be hard to plot. So I'm going to write that guy in its mixed number form. That's 2 2/3, 0. That's a lot nicer. And the second point I found, 0, negative 4. That one, there was no problem with that. So I'm going to plot this guy and this guy. Okay, 2 2/3 on the x-axis. It's somewhere in between 2 and 3. I'd say maybe a little closer to 3. But I mean, as long as you're in there somewhere, that's good. Don't worry too much about it. As long as you're in between. And the next point here, we got 0, negative 4. You're not going left or right, you're just going down to negative 4. There he is, somewhere in that ballpark, right? And we'll just connect the dots. Whee! All right. That's a lot faster, right, I think, than the previous section. It seems like the last section, it took a long time, every problem. But I think it's because we were being more careful since we didn't really... we were in the beginning, we didn't really know what we were doing. Now we feel better about it. And on top of that, in the last section, we were really careful and we found 3 points. Whereas now, I think we feel more confident and we think, oh, we can probably do 2 points. I think as long as I'm careful with all my algebra and my substituting and multiplying, I'm probably doing it okay. So like I said, this is my favorite method. It's really nice. And then how about just throw this in here for fun. For those of you that are really advanced, like this is pretty simple for you. If you think about this last example, we were graphing 3x minus 2y equals 8. Okay, picture that guy. Remember the first thing we did was we let y equal 0 and we let x equal 0 later. You know what you can do actually if you wanted to? You could probably do that in your head. Imagine x was 0 right here. Okay, just do it in your head. If x is 0, then 0 times 3 is 0. That's gone. All you're left with is this part, the negative 2y equals 8. Okay, in your head, if negative 2y equals 8, you can divide both sides by negative 2. 8 divided by negative 2 is negative 4. So all that work we just did in our heads without having to write this whole thing out. So keep that in mind if you kind of are short on time on these problems and you say, oh my gosh, each of these problems takes forever. How am I going to do all this in such a short amount of time? If you get really good at this, you might be able to find these intercepts in your head as long as you're really, really careful. So keep that in mind. I think once we all get good at this, we can probably do that. All right. I think that sounds good. Let's move on to the last topic in this section. It kind of seems unrelated, but it's important as well. So let's see. You notice that all the lines we've graphed in this section and in the previous section, they've all been some kind of diagonal lines. Maybe they sloped up, kind of up and right, or they sloped up and left or something. But they were never a completely vertical line or a completely horizontal line. But there are lines that are completely vertical and completely horizontal. We haven't talked about those yet, but that's kind of almost an afterthought in this section. They say, oh, by the way, there are vertical lines and horizontal lines, and we don't know how to graph them yet. But they're not, once you get the hang of them, they're not too bad. They're just kind of weird. Okay, so horizontal and vertical lines. Let's see. The equation of a horizontal line, it's kind of interesting. It always looks like it's of the form y equals a number. So for example, y equals 3. That's a horizontal line. Isn't that interesting? It doesn't look like the equation of a line, right? It just looks, oops, sorry. Just looks like someone's telling you, hey, y equals 3. But really, that's an equation of a line. Interesting. Okay, and we'll see how to graph those. I guess the way to think of it, too, is why is that a line? This is kind of like saying, like, you know, you look at it and you say, wait, where's x? All these equations have a y and an x. I guess x isn't there because this equation is kind of telling you no matter what x is, y is 3 always. So I guess that's what this equation is trying to tell you. X can be whatever the heck it wants to be. Y will always be 3. Y is constantly the same number every time. It's x that might change. So that's kind of what that really means. And then similarly, the equation of a vertical line, it's of the form x equals a number. So x equals -1, for example. It's kind of weird to think about. It just looks like the solution to one of our equations in chapter 2, right? You solve a long equation and your answer is x equals -1. But there's kind of a second meaning behind that. That's actually a vertical line, which is kind of crazy to think about. But similarly to the last one, the horizontal line, you could think of that guy as, this is saying no matter what y is, x is -1. So they're saying, hey, x can be whatever the heck it wants, y can be whatever the heck it wants, but x will always be -1 no matter what. So I think, and that'll make more sense as we graph these guys. All right. So let's see. Let's just start graphing some, and we'll kind of talk about how do you know how to graph it. All right. So let's look at this first example here. Want us to graph the following: y equals 5. The hard thing to remember is it's one variable all by itself, y equals 5 or x equals 5. I know it's horizontal or vertical, but I have a hard time remembering which one's which. So as it says up here, we're in the top situation. Since it looks like y equals a number, that's a horizontal line. And it's confusing because if you think about the y-axis is a vertical line. But if you have y equal to a number like y equals 5, that's a horizontal line. So it's kind of the opposite of the axes. The x-axis is horizontal, but x equals a number is a vertical line. The y-axis is vertical, but y equals a number would be a horizontal line. It's confusing. But once you kind of memorize which one's which, when y is there, it's horizontal. When x is there, it's vertical. Then it's easy to graph because all you have to say is, okay, it's a horizontal line through whatever the number is, okay, 5, on the axis, this axis. Since they mentioned y, it must be the y-axis. Okay, so all we have to do is figure out where's 5 on the y-axis. Here he is. And then we just draw a horizontal line through that. That's really it. You find this number, 5, on this axis, y, since they mentioned y, and then you draw a line through it. Just the hard part to remember is it horizontal or vertical? You gotta kind of just memorize that, unfortunately. Okay, let's try the next one. We got x equals 8. So I remember that's a vertical line. The way I remember it is it's the opposite of the x and y axis. If you see x equals 8, think about the x-axis and what's the opposite of that? The x-axis is horizontal. The opposite of that is vertical. But like in the last one, I see, oh, it was y equals 5. Let me think about the y-axis. The y-axis is a vertical line, but the opposite is horizontal, so I'm horizontal. Ugh, it's confusing, but whatever helps you memorize it, that's the way to go. So it's a vertical line, like we said, you find this number, in this case 8, number 8, on this axis, whatever the letter is, so x. Alright, x-axis is here, even though they didn't label it. I'm going to find 8 on the x-axis, here he is, and then draw a vertical line through it. There it is. Beautiful. So that's the way I try to remember it. If you do have to memorize, is it horizontal or vertical based on, do you have an X or a Y? But then after that, all it ends up being is look for that number on that axis and draw a line through it. Let's practice it on the next one here. We got y equals -1. I remember that's a horizontal line because it's the opposite of the y-axis, which is vertical. Horizontal line through the number that I'm given, -1, on the axis that I'm given, which is y, since it says y equals -1. I'm going to find -1 on the y-axis, here he is down here, and then draw a horizontal line through it. There we go. Beautiful. Alright, that's it. So these are hard to remember how to graph. You know, you got to memorize this one's vertical, this one's horizontal. But if you have it down, they're really fast. That's the thing. If you memorized how to do it, it's easy and really quick. But if you have not memorized how to do it, it takes a long time. That's the sad part. There's one more here. Let's practice this guy. All right. This is, in my mindset, how I approach these. I look at it and I say, oh, it's X. What about the X-axis? The X-axis is horizontal. The opposite of that is vertical. All right, so this will be a vertical line through the number that I'm given, okay, -4, on the axis that I'm given, which is X. All I have to do is find this number on this axis. Where's that guy? -4 right here. And then draw a vertical line through it. There we go. All right, and don't worry about it being perfect. If it's not a perfectly straight line, I think we understand. All right, I hope that makes sense. Or, you know, that's a lot to process, I know. But I think when you practice them on the homework and try a few on your own, it'll make more sense the more you do. So thanks for paying attention, or trying to anyway, and if you fell asleep, I'm sorry. I'll talk to you in the next one. Have a good day. Bye.